I'm trying to solve a problem I have with one of my circuits. Now it's a bit of a tall order because it's quite a complex circuit, but I thought I might as well just put the video out. Sometimes whenever you talk over these things, you get ideas coming into your own head. So let me explain what the problem is. I'm trying to do just one thing. I have a command which puts a little pixel on the screen. So the command is PIX, and then the next 16 bits tells it which input-output card we're interested in. So we'll see that just in a minute. And then the next 16 bits tells us what colour the pixel is, and then the next 16 bits tells us the X and Y position. So it's just pixel and then 3 numbers. So I'll show you the circuit here first of all and roughly how it works and what I'm trying to do. So I have this thing here called graphics 2, which we can call our little graphics card. Now we'll go down inside and I'll show you the little circuit, and I'll zoom in. I'll open it up a bit so we can see it a bit better. So the way it works is quite relatively straightforward. The command pixel comes in, and the first part of the command is the 16 bits which chooses this card. So in order to choose the card, this value here will be sitting at high, and we're going to have, say for example, that would be a 1 and a 1. So these are now true. So when these are all true, you see this is going live, and this little point here is going live. Okay, so that's all we're really bothered about for the first part. It just picks the card. Okay, now it means that whenever this goes low and the address values change, it doesn't really matter. This point here will still remain high. We know we're dealing with this card. Now the only reason for having this is that whenever the command finishes and I press the stop, this line here will go high, and it will enable the outputs of these registers to the final output. Okay, now it's gone red here at the moment because nothing's been reset or anything, but don't bother about that. It just means it passes the values to the output. So that's basically how the circuit works as far as the input to output, choosing the card. Now the thing that I was working on was the colour and position. So the next 16 bits that come in will determine the colour. So what's going to happen is this value here is going to have the data in is going to have a colour value. Okay, and all we have to do is save this colour value in the register by making this set go high. Okay, so if I've built this little circuit here in order for us to do this. So we're going to have this control set line going high. When it goes high, it chooses this line here, which is the set, which sets this value in here. So that's the first part completed. Now, whenever this goes low, we can see that's gone low, and we've saved that value within that register. Now, this value here will change, and it will change so that it gives the next part of the command, which is the XY position. So these are the XY positions. And whenever this goes high now, you can see it now chooses the top line, which sets it in here. So now we've got both values set within the colour and the X and the Y. So when they're set within the colour and the X and the Y, the next thing happens is the command comes to an end and it goes to the stop and it passes the values out. So we've got the colour coming out here, and we've got the X and Y positions. So the X and Y is a 16-bit, but it gets split into two 8-bits, so you get a Y portion and an X portion. So at this level here, the circuit works fine. It works exactly the way you would want it to work. But there's a problem that I've ran into, and it doesn't matter whether I design this circuit using a JK flip-flop or I design it using a little counter or any other method. I've tried 3 different methods and all of them run into the same problem. And I'll try and explain this problem, and this is where it gets a little bit complicated. Now, you can see that this data value comes in here and it just sits at this point and this point, but it only sits there for a small period of time, okay? It only sits there until a set value somewhere else in the circuit goes low. So when that set value goes low, you know, this value here just goes to 0, okay? So we don't get any value. So it means that we have to time this properly so that whenever this value here, the set value for this goes high, okay? So it's now sitting in this state with the data in here. At that point, we have to do the control set. Now, that's easily enough done because when I head up to the level further up, and try to bear with me here. So when I head to the level further up, what we've really got is we've got our control bus. So this control bus is just the set and the enable, okay? So the enable line for this, whenever this enable line goes high here within the control, it allows this bus value here, which is bus out. So this is the output coming here and it feeds into the graphics card, okay? So the control enable is the line that enables this value onto this point here, okay? So that's the enabled on to that point there. Now, the other part of this is the control set. So the control set comes along here as well. It's just a 2-bit bus. Comes along here and it comes along and it goes into this point here. And this is the point that we use in order to set the value in the registers. So the enable comes along and it pushes the value into both of the registers. And then the set comes along that line and we set one of the values in one of the registers, and then whenever whenever it goes low again, the next set value comes along, we enable the next number in the next register, okay? So that's the way it's supposed to work. And let me go through the actual process and we'll show you what actually happens, okay? Which is just think it's a bit strange. So what I've done here is I've put the actual command in. So the command for the pixel is 7000. So I put 7000 in there. We've got FFF5. So FFF5 is the first number that chooses this graphics card. And then the next number is FFFF, which is the color. So that's the color white. And then the next value here is 0040, and that's an X and Y position. Okay, so it's just pretty much picked randomly, and it's a little dot somewhere in the top left hand side of the screen. And then we've got this 58000, which is just an end command. It's just stop everything. So I should be able to run through this and it should work. So let me just go through. So I'll go through each of the stages and I'll show you the parts that are the interesting parts. So we're waiting for the command 7000 to come in because that's when the start of our command. So you can see the 7000 come in the instruction register. Now I'll go further along. We've got to the FFF5, so we're choosing the graphics card. Right, I'll get to the first point. So I'll get to 1, 2, now this point here. So at this point here, this is whenever we've got the control set comes in. So you can see here, the control set's come in. It's chosen this line here. We've got the value FFFF. It's going to be saved in this register exactly as we would expect. Now the next clock pulse comes along. So when the next clock pulse comes along, this set value goes low. Okay. Now when the set value goes low, I don't want to muddy the waters, but I'll show you here. The set value goes low, and within the control unit, the set value here has gone low. So it means that this control output from the microcoded control unit has been forced to a low position. So the control set has just gone low. Okay, so now that the control set has gone low, we don't expect to see any changes in this circuit, okay? Because it's gone low. At this point here, will not change. Okay, it's sitting at a 0. But the problem I have is in the very next clock pulse. The very next clock pulse, it actually jumps, and it shouldn't because there's no change on the input. So if I come in, and so we have a high in this line here, okay, and the Q is high. So when I come in this next line here, and I go to this line, you'll see the enable and the other clock L go low. So those have gone low, but the set hasn't changed, okay, it hasn't changed at all. But when I come in here, you can see that this has jumped here from the Q was high to the Q bar has gone high. So there's been a change in this circuit from this state here with a 1 here and a 0 here without any change in the input. There's been no change in that input. Okay, and that's what I cannot get my head round about. I don't know why that hat JK has jumped. Now, I designed the circuit again using a D-type flip-flop, which is just like a little counter. So we can replace this with a little counter, which looks like this, okay? And I've put this in here, and it does exactly the same thing. You can actually see that the counter changes from a value of 1 to 2 without there being any change in the clock. So the clock just remains at 0, but it counts another 1. Now, there's not any race condition, and there aren't two values changing at once at an input. There's nothing else happening here. So I cannot get this circuit to work. I cannot get it to work at all. I've tried everything to get it to work. Now, I can actually design the command, and I have designed the command so that it works, but it's a right bodge, because what I can do is I can come in here and I can grab a couple of the sets here from these registers, and I can copy these sets over into my graphics card. Okay, so I can copy these sets and put them in here and here, and I can control them using those two sets from a microcoded control unit, and it works fine. It works perfectly fine. But I don't want to do it like that because it's a bodge job. Because what I'm wanting is the control of this graphics card to be completely controlled by just this control bus. I don't want to have to take out extra, so you can see here I've actually done it here. I don't want to take out extra sets, okay, and run extra sets along here. I only want just the one set to work, for it to work. So that's my problem. I just cannot get that little section there to work. It always jumps. It always jumps even when the input hasn't changed. So that's just wrong. That device shouldn't work like that. Okay, and also the counter, as I said, it counts to 2 without there being a transition on the input. I can't work out. So if anybody's got any ideas, please get in touch and please help me. Okay, thank you, and goodbye.